Hey guys, a very good afternoon, and how are you all guys doing? I hope you all guys are doing very fine and having a good day and had a good week as well. So, this is me, Abhidhi, and what I am going to do today in this video. So, as far as now, I have given you the greetings. Then, for all those who are new, they can check out my introduction as well. And today I thought of starting the video with a motivation, so you'll definitely get through it. And then the actual topic comes up, that is the 7 stages in the life cycle of a star. And next would be the ways to connect to me, how you can connect to me or how you can reach out to me. Then, of course, the outro or the end. Now, all those who do not know me, I'm Abhidhi, and my favorite activities are reading, doodling, and researching. And I like to study more and more as much as I can. And I have a full obsession for books. And my favorite subject is science. And if I'm going to go specially into science, then it's biology only. Now here comes the motivation. Now, when life gives you 100 reasons to break down and cry, show life that you have a million reasons to smile and laugh. Stay strong. Yes, when your life provides you 100 reasons to actually cry, it's just you, like, who can defeat the feeling and have million, I will say trillion reasons to smile. Stay strong. Now, do you know, as I have just now reversed the slide, so do you know that some of the stars we see may be already dead in the sky? So, this is because their light travels billions and billions of kilometers, and by the time it reaches us, the star will be actually dead. The distance between our planets and the stars is definitely unimaginable, but still it can be measured. I hope you learned something new. Now, 7 stages of in the life cycle of a star. So the first stage is giant gas cloud. So now, in the first stage, what happens is a star always originates from a large cloud of gases. Now, what are these gases? These gases are mainly hydrogen and helium. Now, the temperature inside these clouds are very low, so for that reason, the synthesis of molecules can't take place. And till now, there is a giant like gas cloud example is Orion system's Orion cloud complex. And this is what is Orion cloud complex from the Orion system. And it's the first stage, that is the giant gas cloud. Second stage is protostar. Now, when the like molecules and atoms collide with each other inside the gas clouds, the heat energy is being produced, and this always results in the formation of a warm clump of molecules. And this warm clump of molecules is what is referred to as the protostar. And the creation of these protostars can only be seen through the infrared vision, because protostars are warmer than any other material in the clouds. Now, several protostars can be formed in one cloud. That depends on the size of the clouds, definitely. Now, if that was the second stage, now comes the third stage, that is the T-Tauri phase. Now, here the materials stop falling into the protostar. So, as much as the materials were falling into the protostar, there were more number of collisions, and for that reason the protostar was existing. But when the materials stopped falling into the protostar, it really it releases a tremendous, like unimaginable amount of energy. But now, the mean temperature of the Tauri star isn't enough to support the nuclear reactions in the core. So here is the core. Now the T Tauri star lasts for approximately 100 million years, and then it enters to the most extended phase of development, that's the main sequence phase, and it's the fourth stage. And the main sequence phase is actually the stage of development for the star where the core temperature actually reaches the temperature where it can the point of fusion can happen, nuclear fusion. And in this process, the protons of hydrogen atoms are converted into the atoms of helium. And this reaction is definitely highly exothermic and it gives out more heat and it requires and so the core of the main sequence star releases a tremendous amount of heat during the fourth stage or the main sequence. And this is what a main sequence star would look like. Fifth stage is the red giant. So basically it's the giant stars. Now, when hydrogen atoms have been converted into helium ones over the course of life in the main sequence star, and eventually hydrogen is a fuel for the star, of course, so it will run out. There will be no stock of hydrogen, and so the internal reactions or the internal fusions stop taking place. And without the reactions occurring at the core, the star just contracts inwards through gravity, causing it to expand. Now, as the star actually expands, it becomes a subgiant star and then a red giant. Now, red giants have more cooler surface than the main sequence star because here the reactions won't happen in the core. And because of this, these giant stars are appearing red and the main sequence star are yellow in color. This is the fifth stage. Now let's come to the sixth stage, that is the fusion of heavier elements. Now helium atoms fuse at the core and as the star expands, now the energy of this reaction prevents the core from collapsing. Now the core shrinks and begins fusing with carbon. So in the space we have carbon on the top, then we have iron, then other elements are also present there definitely. Now, once the helium fusion inside the core gets completed, the carbon fusion takes place. And then when the carbon fusion completes, the iron fusion takes place. Now, in the iron fusion, absorbs most of the energy, which actually causes the core to collapse. And this transforms the massive stars into a supernova, while smaller stars like the Sun contract into white dwarfs. So it was the sixth stage, and here comes the seventh stage, that's the supernova and the planetary nebula. Now, most of the star material is blasted away into the space, but the core is or implodes into a neutron star or a singularity known as black holes. So, of course, in the space, the star materials get vanished, get blasted away into the space, but the core exists singularly, and in that situation, it is called a black hole. And less massive stars don't explode, but their cores contract instead of a tiny hot star known as a white dwarf, while the other outer materials drift away. Now the stars tinier than the sun don't have enough mass to burn with anything, but a red glow is definitely seen during their main sequence. And the red dwarfs are difficult to spot, but these may be the most common stars that actually burn for trillions of years. Actually, now one of the major questions is: are planetary nebula made by supernova? Well, the answer is here. Planetary nebula are not made by supernova, they both are very different things. Now, a planetary nebula is born when a low mass star, less than, even less than 8 times the sun, 8 times the mass of the sun, it dies, then planetary nebula is formed. But whereas the supernova is the result of a very massive star, even much massive than our sun. So the heavy stars that make them build iron using their elements. So when a low star, like a star having a very low mass, even less than 8 times the mass of the sun, is died, then a planetary nebula is formed, and when uh, like a very massive star, even massive than the sun, dies, a supernova is the result. So as you can see in the GIF, a star is glowing and it's waking up an owl. So now finally we're done with our topic, and then of course ways to connect to me. So well, I'm Abhidhi and my Gmail ID is sciencewithabhidhi@gmail.com, or else you can always comment down in any video of the channel. I'll be checking it out. So thank you so much, and this is Science with Abhidhi. Don't forget to like the video, subscribe to the channel for more and more content, and share it to your friends and to any other person as much as you can. And of course, enjoy the week ahead. And we will meet in the next video with a biology related video, of course. And we'll see you the next time. Till then, take care, and always stay safe during these tough times. And of course, bye and peace.